Hello guys and welcome back to a new episode of this video series where we are writing an operating system from scratch. We are just finishing up our second stage bootloader. We still have a few things to address and we are going to move to something else next once we finish this up. And actually what I want to do is I want to actually poll you guys. I want to ask for your opinion on this. What should we be doing next? Should we move to actually writing a bootloader, a UEFI bootloader, just to go over how modern bootloaders work? Or should we just dive right into kernel stuff and start writing the kernel? In the last video, we have implemented FAT16 file system support, at least a subset of it. So now we have ability to read files from disk and load them into memory, however we like. So that's what we are going to do today. We are going to load a config file, parse it, and then load the executable. So let's get cooking. Oh, right. So this is what we had last time. We have read an example config file, and we have loaded into memory to some address here, and we've printed it out. And what we'll do now is we'll actually just go ahead and create a function here that we'll call load kernel, I guess, or load kernel config, something like this. Right, so let's create that. I'll just forward declare it here. And what this return actually, this should probably return a U8 pointer, which is the pointer to the config contents. But for now, let's just leave it as a void and load. There we go. Right, so here we just need to do the same things, basically. So just copy this over here. And so the one thing that we need to do is we would like to load this config file somewhere in memory that we know will not be reclaimed, because if we go over our definition here, every time we allocate memory, we mark it as reclaimable. And that basically means that when we when our kernel gets executed, it will basically claim back all those memory buffers or those memory blocks that we have allocated this way. Yeah, so what we need to do is we need to probably create a variant of this function here that would load the file to some address that we know we have reserved. Yeah, so let's do that. Let's do that now. Let's just yank the whole thing here and paste it over here. Call this read file to address, right? And here we are going to just take a const void star pointer, call it address. And what we are going to do is, actually we can do this fairly easily. We can just read the file and then copy the file over to the new address. But is there a way that we can just simply copy it over or load it over without having to copy it? So let's see here. We load the directory entries, and then we have, yeah, so this is where we load the contents, and this is our basically address here. So if we just go and do something like this, this shouldn't be const actually. Right. So this here should actually load our contents directly to the address we've given it, without it having to recreate memory for it. Right, and actually, why don't we just make that our API for now? Yeah, I think we should just get rid of this. And this here will be our new read file. So we now need to pass it an address to load things into. So let's go into the okay. Right. So this one here would need to have a void star. Call it address, or should I call it load address? Right. So this one here should be fine. And here we can just basically get rid of these things here. Actually, just want to bring the print over this side and go over here. And now we need to give it some address here, right? So here we will do something. We will do void star, and I will create. So let's call this environment for now. And here's what I'll do. I will declare an extern. So a car table. We call it environment. And this car table here will have a arc page size, so just one page. And what this will do is, so after some thinking, instead of just having this config be the bootloader config, so the config that the bootloader uses to load the kernel and stuff like that, we can actually reuse this config as a way to pass data to our kernel. As in, if we go back to our example file, so let's let's just do this. Let's remove all this. Let's see that we have something like kernel is sys kernel 64.elf, and we can have video be something like 600 x 480, something like this, and then we can have key 1 equals value 1, etc. Right? So this means that we can use part of this config file to actually load the kernel, because we can, for example, see that the file that we need to load from this for the kernel is this one here. But we can also use this file as a way to pass values to the kernel itself. And to do that, we just need to map this variable here, this file that we are loading, somewhere into memory. And once we do that, we can just have the kernel know where it is, and this can be part of our contract with our kernel. So let's do that actually. So this still needs to be defined somewhere. So we'll go to our linker section here, and same way we did this boot info here, we are just going to just do this and just go ahead and call this environment. And here we're just gonna do some address here, 0xb00. And if we go back to start.asm, just take a look at our memory map here. So we have something else at b00, and we need to bump those. So let's do b000 to 0xbff. This would be our kernel environment variables, or config, let's say. So this would go from C00 to CFFF, and this would need to go from D. Oops. Right. There we go. And I guess we are going to move this. Right. So this one would be that, and this one would be E. And that means that we have, wait. Okay, no. Okay, so this one would be C. Oops. And this one would be D. Right. And actually, we just need to go ahead and change this to be 0xDFFF. And this is our LBA buffer, right? So LBA temporary buffer. There we go. And of course, this would be E00. There we go. Cool. So with this, we can go back to our main, and we can get working. So this environment here would point to 0xB000, and we will be loading this file to that address, right? And to, oh, okay, so there's something else that we have missed. We will need to go here in our physical mapping, and we need to tell it that this, right, so we need to bump these. So this one goes to that, and this one goes to D. Right, and we need to basically take this page here. So environment, we need to declare it somewhere here. And this is an arc page size, and this one is a map boot info. Maybe we need to call it something else. Let's leave it at that for now. So let's see where this is defined. This is defined here, and we need to redefine environments somewhere up here. So let's just do it. Let's just do it here. Extern car environment, and this is of course arc page size. There we go. Right, so with this we should be fine. And actually, just one last thing here: read files shouldn't be returning anything anymore because we have passed it the address to load to. In any case, this should probably just return a boolean to say that we have loaded correctly or not. But for now, I'll just leave it at that. Yeah, so that means that this here will just remove the star, and that should be fine. And it means that we are just going to, yeah, actually, let's return the boolean. Right, so is this how we defined our boolean? Yep, this is how we defined it. And of course, we can go over here too and do this. And now instead of doing null, we can just say if not found, return false. Otherwise, return true because we have loaded that here. And if we are out of this loop, we are returning false. Cool. It's pretty good. All right. So let's go back to main again. And yeah, so let's get rid of this and let's see what we have here. We should actually print environment. Not sure environment should be 0 terminated, but we'll assume that it is for now. Right, so we have our config file loaded here. We have the environment filled. So now let's take a look at load kernel file. Let's do this, load kernel, right, and we can just go here, void load kernel. Right, so what do we need to do here? First, we need to parse the environment file and find an entry with, so the kernel file is given by the entry kernel equals something, right? And this entry here can occur on any line, so we can't expect it on the first one. So we need to basically go line by line and parse the file basically to find if the line starts with kernel equals. And of course, yeah, I should probably do this. So if I have to write it as a, yeah, let's do something like this, right? And here we'll have a new line, which is the termination. And here we'll have the end of the line. So this is basically in regex syntax. So this means that kernel here should occur at the very beginning of the line, and the line goes all the way until we encounter a new line. Right, so let's do this. What we'll need to do is probably just have a U8 pointer, which will be our sort of cursor. And this one here will be pointing to environment. And we'll do, so we'll loop over the cursor. So while we have something under the, under the cursor, we will, so we will want to stir comp, so stir and comp, so cursor, cursor, and our other string will be, I guess we could just define it somewhere here. Yeah, we'll probably need to clean this up later, but for now, let's just define this. So car kernel entry, this will be something like kernel equals. There we go. So we'll compare this to kernel entry, and of course we know that the size of the kernel entry is just size of kernel entry. And if this is equal to 0, that means that we have found our kernel entry. But otherwise, actually, let's do the case where this is different from 0, and then we'll see what we get. Right, so if this one is different from 0, we will need to basically reach the new line, because we know that this line here that we are on is not the one that we're looking for. So we'll loop over our cursor, and while our cursor is different from the new line character, we are going to just basically keep moving it along. And if we found the new line character, then we know that the next position is the new line. So we is the actual new line, as in the line that's after the one that we are on. So we move cursor just one spot more, and then we can just basically continue the execution of this loop. Otherwise, if here is not basically not 0, so we found our match, so we can just break out of this loop. And here we should have two cases. We should have either the cursor that contains nothing, because basically we have reached the end of our config. We haven't found a position where we have the kernel, and otherwise we actually have our cursor that's pointing to the line that has kernel. So let's check if cursor has something, and we can now assume that this is our kernel config. So we can basically print something that along the line found kernel entry in the kernel file entry in the config, something like this, and we should just so we'll move the cursor along with size of what did we call that? Kernel entry. There we go. And that basically means that we are now pointing to oh yeah, of course. Yeah, no idea why I used size of. It's very weird. Right, so here we have cursor that has been moved with the sterling of kernel entry, which should be 7 maybe? Hold on, so 6, 7, yep. Right, so now we just need to copy that value to somewhere else, right? So we will, what should we do here? We should probably create a car, what should we call this? Kernel path. And this will be what? This will be 256. I guess that should be enough. And we'll just leave it at that for now. So here what we'll need to do is we'll need to copy the line that we found into that location. So we'll copy into kernel path the cursor, and of course the length should be the length of cursor. The issue with this is cursor, or the string under cursor is not 0 terminated, so string will basically probably give us the size to the end of the file, and that's not what we want to do. And so what we need to do here is let's fix this to 256, right? And let's do we have memset? We'll have memset, okay. So we'll need to implement memset, and we'll memset kernel path with zeros. So we'll fill it with zeros, and then we'll copy it, copy 256 from cursor to the kernel path. Actually, we will probably just need to do it manually, because we have a stop condition, which is cursor reaches some kind of space. So if cursor is some space, or oh, actually this should be different. Yeah. So if our cursor is different from space, and our cursor is different from, let's say, new line, probably even take into account that our cursor should be different from something like a carriage return or something. And if we have all these, that means that we need to copy it over. So kernel path of I is cursor. Right, so we need to define what I is, and I should be u32, I starting at 0. Oh wait, yeah, okay. So it's been a while that I haven't worked on this. Right, so this should be a u8, and did we define this as right? This one would be u8, and this one should be u8 also. Okay. All right. Okay, so we have copied this. We need to advance both the cursor and the eye here, and this will go on until we hit one of these conditions here. And of course, once we are done with this, we should do something like kernel path of I should be 0, right? Just so we can terminate our string properly. And actually here we should have another condition, which should be I is less than 256. Otherwise, we run the risk to overflowing our buffer. Okay, so we should probably just go ahead and write set in a bit. But so now we can just probably finish this up first. Let's printf loading kernel from path and something like this. And this would be kernel path, right? Right, what do we need to do here? So we need to allocate some memory. And then load the kernel into there. So let's call it void star. Kernel file will be pmalloc. And this one, so we need a size here, right? For now, we don't know what this size is. And that is a bit of an issue. So what we'll need to do is have a function in our file system handling that basically does a stat on the file and returns us a sort of structure with file info, including the size, for example. Right, so we'll do that in a bit, but for now we'll just call this so a map. I guess this one should be reclaimable. Yeah, I guess this one should be reclaimable, right? So a map reclaimable. There we go. Okay, so here let's do this before we forgot to do get file info. Yeah, that should be fine. Should probably use size. Okay, so we get the file info, we get the file, and once we have the file loaded, then we need to basically. Oh, actually, this one is not the file. This one is just the memory for the file. So we can call read file. And read file takes a path, which is our kernel path, and it takes a load address, which is our kernel file. There we go. So with this, yeah, of course. So it should be const i8 star. There we go. Right, so with this we have our kernel file loaded somewhere. So we just need to return, probably return the kernel file path, kernel file, right? That means that we need to go here. We need to set this as a void star, and we need to go somewhere here and set this as a void star also. Okay, that looks good. So we just need to implement memset and implement some sort of function here that gets us our file info, I guess. So let's do something like, I guess we can call that file info. What should we call it? Kernel file info. And this should be something like find file, maybe. So what should it take? It should take just a path, I think. So kernel path. Yeah, should be just this. Does it need something else? I don't think so. I don't think so. Right, so we will go ahead and implement those two then. Let's cook. Memset, I guess we should probably just put it into strings.h. Yeah, already have memcopy there, so it should be pretty much the same thing. Right, so this one here would be memset, and I guess we don't have a source, so we can just remove that. Right, yeah, actually, yeah, forgetting something very important. This one here should be a U8 or I8. I guess we don't really care. This should be some character that we're setting. Okay, so let's implement this. Go here. Probably just go into yank this. Actually, I'm gonna move that all the way down here, just to group them together, and just do this, and now we'll just change this to nameset. And of course here, we said I8, call it C, I think. The implementation itself is pretty much the same. So we just change this to C. And we change this, of course, to C also. Yeah, actually, we will need to do something more here, because we need to pack. We have C as an I8, and we want to make changes 4 I8s at a time. That's what we're doing here. It's our cheap version of SIMD. So we'll need to pack 4 of those, 4 of C's into some value here. So let's create a U32 or an I32. No, I guess we're doing bytewise things, so, or bitwise copy, so we'll just leave it at U32. And we'll call this pattern, initialize that to 0, and then we'll need to, actually we can just do it here, right? So we can do, so we have C 24, right? And we OR that with C 16, we OR that with C 8, and we OR that with C. Right, so this one here will complain because we are changing the signness, but we'll just convince it that we are not, because we're doing bitwise copying, so don't need to worry about those. Yeah, don't worry about that. So U32, oops, of those, everything in here. There we go. And that should be fine. And that means that here we need to put our pattern instead. Right. Of course, this one here needs to be I8, since we are, yeah, since we said that this one is an I8. Right. And that means that we can just go back here and set our I8, this to I8, I guess. Right, looks pretty okay. So we'll do a bit of a test and we'll see what we have, but for now it should be fine. Right, so if we go back here to main.c, so we just need to basically figure out a way to implement this find file function here that returns something like, okay, actually, just rename this to something better. File info, and we'll go here. So we have partition info, we have fat info, and we should probably just add a typedef struct. We'll call it, yeah, we'll call it file info. And here file info will have, so a U64, which will be the size, I guess. And I guess that's it for now. I don't think we need anything else for the moment. Actually, let's see what we have here in their entry. We have creation times, modification times, attributes, name. Yeah, nothing of that is really interesting to us for the moment. So yeah, we'll just do it this way. So file info, find file. This takes a const I8 star, which is the path, and that's pretty much it. So let's copy this and go over to here, where we'll just do this. Right. So what do we need to do? Actually, I think we pretty much need to do the same thing that we are doing here, except for this thing. Huh. Actually, we could reuse this. So basically what we're doing here is we are trying to find our file, and if we find it, we load it. It means that this function here can actually be split up into finding and loading the file. So let's, yeah, let's copy this whole thing here. We'll see what we get. So if we have the file, instead of doing whatever we're doing here, we are just going to return, so file info. We need to create a file info here, info. Somehow, but what do we do otherwise? Because we need to signal if we haven't found the file. Right. And file info can be a, I'd rather it not be a pointer. So what we need to do probably is something like found, something like this. Yeah, all right. Right, actually, let me just go ahead and define a file info up here. So file, just call it info. There we go. Right, so here we haven't found the file. So it means that we are going to do info dot found equals false. Otherwise, here we're going to do info that found is true, and info dot size would be entry dot file size. There we go. Cool. And I guess we could just return info here. There's no reason to continue, and we can just return info here also. And this one here would need info.found. Actually, I'll just do it here. There we go. Maybe we can just be a bit smarter about how we're doing this. We can do something like found equals false. There we go. Of course. And here we just need to, yeah, of course, return info. And here, if we have found it, we set found to true, and we set the size to the file size. Actually, can we not also put the directory entry into the file info? So directory entry here is a pointer, and we call loader entry, which checks the pointer. What does it actually need from the directory entry? It needs the first cluster. Is that all? Is that all we need here? I think that's all we need. So does that not mean that we can just change this whole thing here to just have, yeah, so if I go here and I add, sorry, not knowing what it is size-wise, but first cluster. Actually, let's check what it is size-wise. First cluster, U16. Okay. Right, so this one here is a U16 first cluster, and that means that we now can just send this around instead of having to send the whole directory entry. Okay, so let's try to do that. So I guess here we need to do info that first cluster, first cluster, there we go, is entry first cluster, there we go. Okay, and that means that we now need to just So this loader entry just needs the first cluster ID. So does that not mean that we can just change this whole thing to a U16 first cluster and be done with it? Something like this, first cluster. Okay, and that means that we now have to change all these things to be entry first cluster. And we need to go over here, do something like this also. So this would be first cluster. Of course, this one to be first cluster. Okay. I guess we still have the same one here. Yep. So first cluster. Right. Okay. And now can we not do something for this read file? So let's try to re-implement it here. So let's see here. Right. So what we need to do is get a file info from find file. File, nice. File just takes the path, and then we check our file info. So if not info.found, so here we just I guess panic, or not panic, return false. Oops. There we go. Of course, okay, never mind that. Right, so if we have found it, then we can just load it the same way we do here. So we just call this basically, right? Yeah, so let's yank that and do something like that. And here, of course, we don't have enter, we have info. And of course, this one is just a dot. Okay. Right, so if we now take this and put it somewhere here. What do you mean? Oh, of course, file. Nice. Find file. Actually, all right. Okay, so read file 2 should be better than read file 1, but we'll test it and see before we actually retire this one. Right, so let's go back to our main. Here we have this, we have find file. Did we not declare it? Or is it just missing a... okay, cool. Right, okay. That should be fine now. So find file is fine, and here we can just change this argument to be file info.size. Oops, yeah, that's not the argument we want to change. It's this one. So file info.size. Kernel file info, actually, just kernel file info. And yeah, kernel file info dot size. And of course here it takes a U32, so let's change file info to have a U32 size. And I guess that should be it. Right. So if we go now to this, what's the right. Okay, so let's just tell it that it's fine. It's a const i8 star. Just get on with it. Right. So this to do is done. Okay, we have our kernel path here. We are trying to load our kernel here. And actually, this is nice because we can actually pass to read file. We can have a read file, I guess read file 3 or something, that could, so basically it's just copy this and paste it there. We can set this here, and we basically just need to do this, right? So if I change this to be a file info star, file info, file info, of course this one is a pointer. This means that we don't need to basically do the find file again, just to get back a file that we already know exists, right? So let's go to main, and we can use that. Here we can just give it a kernel file info. There we go. And here, of course, it wants it to be a const. Actually, we can just define it to be a const here, can't we? Okay. So this one needs to be read file 3, which we haven't defined yet. So let's go here, and we will do something like this and this. So this one would be 2, and this one would be 3. And of course, this one here takes a file, a const file info pointer called file info. Okay. So let's see here. Oh yeah, of course, this one here needs to be const. There we go. Oh, right. Okay, so this one is happy, and we should now be doing the loading correctly. So what's the thing here? Passing const u8 star const, right. Because we've defined this as a const u8, and we said that this here takes a const i8, right? So const i8 star. There we go. And I guess the same goes for these two here. So const i8 star, cursor, and const i8 star, kernel entry, and I guess the same goes for this one here, const i8 star. There we go. All right. Yeah, probably should have just set this to i8. That makes this useless. So, and it also makes this useless, I think. Yeah. And kernel path should be fine. Yeah, so the rest should be pretty good. Okay, so let's see here. Let's try to build this and see what we get. Right, so we have no new warnings, so let's run this and see. Okay, that looks pretty good. So loading kernel from path, syskernel 64 elf, found kernel entry in the config, and the config file that we've printed contains all the key values that we have added into the example. Right, so let's now see what we can do with this and see what we have, because we need to actually make sure that our kernel was loaded correctly. So we will actually need to so let's do something like this, okay? Printf and found kernel file. Actually we have a big issue here. So if kernel file info.found, or if not .found, just do it this way. We basically, while one, we haven't found the kernel file, and we should printf error. We should do something like this. Panic. No kernel file found at. Yeah, we can do something like this. And here would be the kernel path, right? Right. Otherwise, we have found the kernel file, and we should probably do something like this. So size is equal. Our size is U32, so that should be fine. Just do this, and first cluster would be U16, so it should be fine to do this also. Right. So file or kernel file info dot size and kernel file info dot first cluster. There we go. Oops, there we go. Let's format this and see what we have. Right, so let's give this another compile. Let's see, do we have new warnings? No, we don't. Let's do this. And now we have the error we are expecting, because we have no kernel file there. We have no file at sys kernel 64.elf. So let's put a test file there, I guess. Right, so let's put a test file there. And what I'll do is I will actually go over here. So see that here we are copying our boot config to BIOS boot.con. I will change that to be, because I want this config to be part of the kernel, not part of the bootloader. So I'll change that to be sys, and what do I call this? I guess kernel.con. Yeah, that should be fine. What we need to do now is actually just, duplicate this, change this to be sys. Actually, we just need sys. We don't need the rest. And so now this folder exists. We need to copy that into that folder. And we need to copy some, I guess, kernel placeholder .txt to image sys kernel 64.elf is what I'm guessing we'll do. Right, so now let's just make a new file, kernel placeholder.txt, and let's print something here. Placeholder, and let's give it a size. Actually, let's give it a bigger size. just copy this a few times. That should be fine. That should give it about 1 kilobyte, 1.3 kilobytes of size. So let's see. This one here, did I spell it correctly? I think I did for once. All right, let's, oops. Do we have any errors here? That should be fine. And it also means that we can just go ahead. Relative paths not handled. Of course. Yep. Of course. So we couldn't find the config file because we haven't changed the path we are expecting it to be. Actually, this one here can go all the way up here. There's no reason for it to be down there. Right, and this should probably be renamed. Now, let's rename it config file path, like this. And of course, here we know that this is no longer in BIOS boot, it's in sysboot.con. Right, okay, let's try this again. Second try. Okay, let's see. Okay, so we still have the same error here. Relative paths not handled. Does that mean that our file is wrong somehow? So let's take a look at what we have here. Wait. Okay, so we have placeholder.txt. Okay. So why is that not getting copied to where it should be? Oh, right. Okay, my bad. My bad, as always. Right, so this one is no longer boot.con. This one is, so boot, yeah, so this one here is kernel.con, and this one should be 11 still. So let's see here. So have 6, 7, 8, and 3, that's 11. Cool. Okay, let's try this again. Okay, so no kernel file. Kernel 64.elf. Cool. So let's see what we have here. Sys kernel 64.elf. That one should be fine. All right, okay. So let me just mount the disk file just to see what we have in there. All right, so let's see what we have there. So let's image, we have sys and BIOS, and if we go image sys, then we have kernel 64.elf in there. Oh, I see it. Kernel 64 is, the name is too big. It's not 11 characters. That's why it's never finding it. Right. Okay. And of course, okay, I see what the issue is. So let's go back to main and let's see what we have here. So first of all, let's go to our make file and make sure that this here, actually it's not too big, it's just the right size, but we have this dot in the middle. So this is 8 and we have the dot and then the extension. So in our config file, we should probably do something like this. Yeah, because we haven't written any function that basically parses the dot to the FAT16 format, which is just a 11 characters buffer. It has the 8 characters for the name, padded with spaces if needed, and 3 characters for the extension. So yeah, we'll see if this makes it a bit better here. Of course, I should probably just undo what I did here. So umont image, and let me just remove that. Okay, so that works. Let's see if we have. Oh, right. So maybe it's just this. So let's give it a try. Oh, right. So after a bit of a debugging session, I found where the issue is. So here in our start.doc implementation, we had a bug where we basically got out early here in this check, and we never actually found that the string has terminated this string here that we are we passed as an argument. So I made changes to fix that basically, and that's what we see here. So if we go this and build it now, yeah, we can see that we actually now find the kernel file. The size looks correct, and the first class also looks correct. So let's try to print that file. There we go. So we get the kernel file, and then we can just go ahead and call printf on that. Yeah, kernel file like this, and we do something like this. It's probably going to be an issue, but actually, let's not print the whole thing because it's going to basically take the full console we have. So let's do something else. Let's just print the first four characters as hex actually. So let's do u32. So u32 pointer kernel file, and we'll actually need to dereference this like so. All right, let's give it a try. All right, and we have 74, 20, 69, 48. So let's see what we have on our file itself. So xsd build kernel placeholder. Yeah, of course. Right. So we have 74, 20, 69, 48. So that looks pretty much the same as what we have here. So we have our file loaded. Oh, right. Well, that was it for this one. So what we did here is we parsed the config file, we loaded the kernel file from where it was defined in the config, and we also thought a bit about how we can send data to the kernel. So now we have the boot info struct that we can actually just pass it to the kernel directly, and we can also pass it some configs that are defined by the person that writes the kernel, which is what we call the environment. So now we have actually enough to work with here to pass config plus information about the system to the kernel. So this, I guess, we can mark it as solved. So for the next one, we are going to load an elf executable instead of the placeholder we have now. And this is actually an excellent transition to introduce the new video series that I've started working on, which is called Scalpel. And it's basically a primer to different subjects that we are going to need for this, for writing this operating system. So I have a video there on the elf format, if you want to take a look at it. Well, that's it for today. And until next time, see ya. Bye.